Dear brothers and sisters, welcome to Mission Viksit India, a channel dedicated to bold ideas that can help transform India into a fully developed nation by 2047. Today's topic is not just academic, it is strategic, urgent, and nation-defining, because in the coming decades, countries will not be judged only by GDP, highways, or exports. They will be judged by who creates frontier knowledge, who owns critical technologies, and who educates the minds that shape the future. Today we discuss two pillars that will decide India's scientific destiny. First, quantum biology, and second, frontier tech systems engineering. Stay with us till the end, because this is also a public call to action. What is quantum biology? Quantum biology is the science that studies how quantum mechanics operates inside living systems. It explores questions such as why plants capture and transfer solar energy with remarkable efficiency, how enzymes accelerate chemical reactions far faster than classical chemistry predicts, how birds and animals may sense Earth's magnetic field, and how quantum effects may influence molecular behavior in DNA. This field sits at the intersection of physics, biology, chemistry, and computation. And let us be clear and responsible here, quantum biology today is mostly fundamental research, not mass-market technology. But history teaches us something important. Fundamental science becomes applied power when nations invest early in education and research pathways. Those who wait until commercialization arrives, they always remain followers and consumers and not creators. India and the world, the real gap. Across the world, leading nations have already recognized this convergence. They may use different degree titles, but they are building structured pipelines, such as dedicated doctoral training, interdisciplinary research centers, quantum-enabled life science programs, and bio-inspired engineering tracks. These are the building blocks for future-ready nations. India, however, faces a specific problem. We are not short of talent. We are not starting from zero. Indian scientists already do excellent work in pockets across our top institutions and in foreign labs. What we lack is the bridge, a structured academic pathway that takes students from classrooms into convergent frontier research and engineering roles. Without that bridge, brilliance remains fragmented. Actually, our education system is still silo-based. Physics, biology, engineering, computation, all taught separately, while frontier science demands convergence. Secondly, India's research and development intensity has stayed very low when you compare it to the major technology powers of the world. Our lower R&D means that the journey from ideas to real-world footprint just moves a lot slower, in snail pace. And another big challenge is that India doesn't really have a mission mode framework for convergent sciences. That's the kind of framework that actually pushes institutions, funding, curriculum, and industry to all move forward together. This isn't about individual failures, it is actually a gap in the system itself, which requires redesigning to cover new frontiers at a speed and precision. Frontier tech systems engineering. The sovereignty core. Now here's an important distinction to keep in mind. Quantum biology is definitely emerging and it's foundational, but frontier tech systems engineering is already something we need for sovereignty. It's an urgent necessity right now. So, frontier tech systems include a bunch of really cutting-edge areas like photonics and optical systems, quantum hardware and quantum information advanced materials, and nanoengineering, AI systems engineering, and also precision sensing, timing, navigation, and metrology. These technologies actually underpin things like national security, space missions, semiconductor independence, climate and energy technologies, and advanced manufacturing. Without mastery of frontier tech systems, no nation remains strategically independent. Quantum biology feeds ideas into this ecosystem, and frontier tech systems turn those ideas into real capability and power. What India must do academically is not about inventing an entirely new system overnight. Instead, what India really needs is structured academic courage. We respectfully propose B.Tech minors and M.Tech specializations in areas like quantum biology and bio-inspired engineering, as well as frontier tech systems engineering. These pathways should be hosted within existing IITs, IISc, NITs, and other leading universities, breaking departmental walls instead of creating more silos. The curriculum must integrate physics, biology, and engineering, along with computation, sensing, and materials, plus theory, laboratory, and mission-oriented projects, all together. So, this is not about just adding more subjects, it's really about redesigning how India trains problem solvers for the future. This is a direct appeal to Honorable Prime Minister, Honorable Ministers of Education and Science and Technology. India has the talent, India has the youth, India has the ambition, but talent without pathways leads to migration, and ambition without infrastructure leads to dependence. If India wishes to be an innovation and inventor nation, not merely a consumer market, then frontier science education cannot remain peripheral. 2047 will not come through old syllabus, it will come through convergent education, frontier tech capability, and scientific leadership. This is not a political appeal, it is actually a civilizational necessity. Dear brothers and sisters, do you believe a truly developed India is one where frontier science stands at the core of education, not at the margins? And, do you believe quantum biology and frontier tech systems can become India's next scientific revolution? Share your thoughts in the comments. Also, write to AICTE and the Ministry of Science and Technology, and don't forget to subscribe to Mission Viksit India for more conversations on India's scientific future. Jai Hind.